Okay, well, it's 3 minutes past now. I will do a couple of minutes of introduction before I hand over to the people you're actually here to hear from, not me. So I will move on to my next slide and do a little bit of introduction. So as I said, my name is Joyce Dalgleish. I work in the data division of Scottish Government. And one of the things that I get to do as part of my role is support events that are part of the Data Labs public sector community. So there's a space on there which is all devoted to public sector, and we over the last year we've been bringing some events to that group. So it's an ongoing collaboration between ourselves and the Data Lab, and these sessions highlight projects that that are about innovation and that speak to the public sector. And excitingly, this event is part of the Data Labs community's Geospatial Data Month, and there's lots of stuff on there, so do check that out. We are recorded, which is why you can only see our faces right now, and the cameras and microphones will be switched off. So do add your questions to the chat, and I'll pick them up at the end for our speakers. And we'll take as many questions as we can. So we'll then share any material. It depends what comes out, we'll find out what you ask, but we'll share any follow-up material on the Data Lab community page, and if you're not a member, why not, please join, and I shall move on to the introduction bit of the event. So today we are going to be introduced to the idea of connected vehicle data and how it can be used to better understand the performance of road networks. We have two great speakers today to bring to you, and we have Dr. Neil Ferguson from the University of Strathclyde, who's been doing some really interesting research, which public sector colleagues in Transport Scotland have been providing assistance with. And alongside Neil is David Lilo-Trines from Compass IoT, which is a road intelligence company based in Australia. So we're here till 12:50. I'm going to stop talking very soon and hand over. And the first person I'm going to hand over to is David, who's going to give us a 101 on connected vehicle data. So David, are you good to go? You are. So do you want me to stop? I'll stop sharing and I will hand over to you, and then you will hand over to Neil, and then we'll all wrap back to do the questions and close. Okay, so over to you, David.
Thank you, Joyce. Hi, everyone. It's really good to be speaking to a whole bunch of folks in Scotland. I'm calling in from Newcastle in Australia. So it's 9 p.m. I've got my cup of tea, and I'm just really excited to meet you all. Just to give you a real quick overview of connected vehicle data. So Compass, among other organizations, provides, I guess, telemetry, or you might have heard probe data before. But I wonder if you remember, if you're a transport or traffic engineer, the gold standard has been the floating car survey. So you put someone in a car and you send them around the network, and they do things like measure travel time and things like that. So imagine that times, thousands of vehicles, basically at any time or day of the week or month that you want to know. So lately with connected vehicle data, we're able to essentially see what vehicles are doing on the network. They know more about our road network than we do. And so there's a cool saying, an academic that I heard say, why model what you can measure? And it encompasses about that. We just measure what's happening on the network. So to give you an idea of what that looks like for any data nerds here, hopefully there are a few. I'm showing you a spreadsheet, and what you can see here is there's actually one vehicle. This is in a place called Brisbane in Australia, but this Toyota Kluger we can see is traversing the same edge or OSM link, or section of the road essentially. But what's cool about this is that we can see every single time it's giving us a data packet, we can see a lat long or a GPS point or position every 2 to 3 seconds as it travels down the network. So from that, we're getting variants like speed, accelerometer, which means we can understand things like braking and acceleration behavior, swerving left and right. And then what we do is match that to the road network. And so if you think about that times many, many vehicles on the road, what it kind of looks like is this super overwhelming image that I'm showing you now. But this is essentially all of those little spreadsheet lines overlaid on the map. I think this is the last few months in Edinburgh. And you can see vehicles moving through the network. You can see this heat map of sort of red is where there's more harsher braking or swerving. And these super red lines are where we can see vehicles might have lost traction as they travel on network. So there's many, many ways we can understand, harness, visualize, and draw insight from connected vehicle data. So I might sort of stop there. And I know I've only been speaking for 3 minutes, but I think that's probably what you need to understand kind of the picture that we're painting here today. Does that make sense, Joyce?
Yes, it does. I'm just seeing in the chat that some people are maybe not seeing the image. So, David, you're sharing an image of Edinburgh, which looks like the roads have become hedges, actually. But it looks like
Yeah.
there's some people not. I'm not quite sure what the answer to that is, Paul, other than log in and log back out again. Which is the classic. But some people are getting it, so I'm not quite sure what's going on. But
I
there
think
are
we're recording this,
visions there.
so hopefully they'll be able to
Yeah,
see it later.
yeah,
But
good.
yeah,
Yeah,
just
good.
laying I guess, the foundation. Yeah.
Yeah. Okay, that's great. Thank you, Drew, for doing that. That's really helpful. So shall we? So with that sort of quick primer about the data, we shall move on.
Good.
Thank you very much.
So, Neil, are you over to you now?
Hold on, I'm just slightly different from what. Yeah. Okay.
Okay, that's come through for me, David.
Right.
Yeah.
Okay, can everyone see that? Yeah, hopefully you can. Yeah, brilliant. Anyway, so this is, thanks very much to Data Lab for the opportunity to present today. Just a little bit of background from me to begin with. I've been involved in quite a number of transport resilience and adaptation projects over the last 10 years or so, including a piece of work we did for the Scottish Road Research Board on the vulnerability of the road network to flooding. That really, in addition to that report, it resulted in quite a lot of conversations with Transport Scotland and those working in local government as well, and in addition to operating companies. And through that sort of process, we sort of were introduced to Compass, who told us about their data, and we thought it was quite an interesting opportunity to explore what that data was able to offer at the route and the network level, but also what happens to vehicles in and around incidents that cause disruption around the network. And so as part of that sort of exploratory sort of phase of what we're doing, we have 1 month's data from Compass centered around Storm Babette that occurred in 2023. So I'm not working in this alone. There's a few other colleagues who have been involved in the work to date. So the aims of the project, which is ongoing, I should add, is firstly to understand at a detailed level driver behaviour in response to incidents, kind of following on from what David was illustrating in his slide, looking at speed and braking, but also zooming out a little bit and thinking about rerouting, and also asking the question, to what extent can this tell us something about postponed or cancelled journeys in adverse weather conditions. We also thought that it was a good opportunity to identify vulnerable locations across the entire road network, which isn't straightforward, given the kind of split between trunk roads and local roads in the country. And at a kind of stretch objective was to try and quantify the operational impact of adverse weather on the road network. In terms of this project, it would be, well, what's the impact of Storm Babette on the entire road network? But I think there's also an important longer term piece around monitoring and evaluation of performance in response to climate change and adaptation, which I think is an important thing. And Climate Change Committee, amongst others, are arguing that we should be better at that sort of thing. I'm sure many in the call will remember Storm Babette. happened at the end of October in 2023. Really heavy rainfall. In fact, in Angus, it was the wettest day on record in over 100 years. In addition to heavy rainfall, there were strong wind gusts across much of Scotland. There were multiple road and bridge closures. There was a red weather warning, do not travel, in the east of Scotland. So there's a lot of disruption, not just a single incident, but there were multiple incidents across the network, which we thought was an interesting case study to explore. So the data set, as I said, encompassed the Storm Babette episode, but it was 1 month's work, so we had before, during and after data for the whole of Scotland, and that amounts to quite a sizable chunk of data, 570 files, about 60 megabytes each, and you can see the sort of at a sort of high level and a slightly zoomed in level the data that we have, and also a single trip. So you can, one of the things we've been working on a lot is queries around travel, individual vehicles or groups of vehicles on certain parts of the network at certain times, and so we've done quite a lot of work at quite a foundational level. But I think David explained the data. One of the things we've been doing is working around a sort of open source approach. So we're using PostgreSQL database with OpenStreetMap and QGIS, which Compass linked to anyway. We could link to other geographical data sets, Ordnance Survey, whatever, but we decided that that kind of generalization across boundaries and so on was a better approach to take. Now, in order to get acquainted with the data, we didn't plunge in and look at the whole of Scotland. And so what I'm going to talk today about is just a small part of the most remote part of Scotland, which is north of Scotland. So we deliberately decided to look at the north of Scotland because there were only 2 incidents on the network at that time during Storm Babette, but also the traffic levels and the route options are fairly limited. And I think in terms of getting to understand the data, validating the results of queries that we're asking of the data and so on was much easier than trying to plunge into a more congested or busier part of Scotland. So we're looking at the north of Scotland only, and basically any trip in or starting or travelling through the north of Scotland was included in the data. So that sort of narrowed down the data set quite considerably. And the 2 red stars there indicate 2 incidents that we knew had happened on the trunk road network on the 21st of October. Actually, incident 1 turns out to be several incidents, as often is the case when you've got heavy rainfall. Flooding appears at multiple spots along the road network. This is the A835, which links Dingwall or Inverness with Ullapool. And there was a flooding incident that started around 2 o'clock, actually started a little bit earlier according to the Compass data, and ended later in the evening. So this is the tweets coming from Traffic Scotland alerting drivers about the road closure and then opening up later in the day. And here's what it looks like if you're driving along there. This is the location of one flooding incident, and this is just further along the road at another source. There's actually a river that runs quite close to the railway, which might be part of the, well, is inevitably part of the story here. The other thing to mention is one of the things that's quite interesting about remote parts of Scotland, but maybe not on the same scale as Australia, is the fact that you know, where there are often not very many good alternative routes if one road is closed. So, for example, here, if you're not travelling on the A835, the diversion route is 50 miles or more in length and considerably longer in time as well. So we look at, I mean, just to give you an idea of the kind of things that we can now do quite easily with the data. If you look at the data from the eastbound direction of 835, we've got speed against distance. This is a vehicle that's traveling prior to the road being flooded, and you can see it just varying speed naturally as it sort of goes along the road. 751 actually picking up the first flooding incident around 14 kilometres along the section of road we're looking at. 1400, the incident's still ongoing. 4:30, we get the picture. We're picking up more of 6 o'clock and later on. And actually at that point, you can see the two flooding incidents occurring where vehicles have been brought to a stop. Whether that was because of traffic management or because of the flood conditions, we don't know. And that's part of the story of connecting in data sets together at a later point. Similar thing with the westbound direction. These are individual vehicle traces, I should add. You're picking up the same location of flooding. And that's what the overall picture looks like, fairly consistent, and we think we can pick up these sorts of incidents across the network if we can go looking for them. We also looked at vehicle trajectories. So this is distance against time. So we're interested in, well, what difference does it make if there's a bit of flooding, a bit of traffic management around the incident. And so just top left to bottom right is with time. We've got distance against time, and so you can see where vehicles are stationary with the horizontal line, and you get an idea of the variation in journey time resulting. So, you know, from about 12 minutes in fairly open conditions to 20 minutes, maybe a little bit less, when the road is affected by flooding. So maybe not all that important in time terms, but maybe if you were catching a ferry, I suspect the ferries weren't working that day, but if you were, then maybe 5 minutes makes a difference. We also looked at acceleration against distance, and you can see most of it is operating in a fairly safe zone. I believe minus 0.5 is considered quite high, and there's a couple of points there, just one sample, so probably need a bit more data to understand this a bit more, but you can see that we can look at how vehicles are braking along this section of road, bearing in mind that the weather was pretty poor at 6 o'clock on October the 21st, and it'd also be dark. So that's for vehicle safety is one of the things that we think is of interest here. Incident number 2, we did the same things, but I want to highlight rerouting here. This is on the A9 between Dingwall and Tain, north of Scotland. We've got pictures of this flooding event. Vehicle was stranded in the water, impassable, and the one on the right is the kind of aftermath when the flood water was still around, but I think the road was open at that point. So a similar story, but what we also looked at here was routing, and so we can see that there's sort of alternative routes here from just between Alness and Tain, which is sort of part of the longer route, and we can pick that up before noon. You can see the section of road that's closed if you look at afternoon, after 12 o'clock, and you can see how traffic is organising itself around about that closed section of road. Individual vehicle trips, we can pick out one vehicle diversion A, another vehicle on diversion B, and thinking about delay and so on. We could also look at sort of other more detailed aspects about speed selection and acceleration, deceleration along these diversion routes as well. But we haven't done that yet. Okay, so but just giving an example of what we've done. There are some discussion points that I think are probably worth spending a little bit of time on. In terms of, so thinking about the compass data and also thinking about vehicle behavior, I think certainly we can gain novel insights into vehicle speed, deceleration, acceleration on road sections which have been directly affected by incidents. We can look at rerouting in response to incidents, but we've got to bear in mind that all we can see is the observed route that's been selected. But we can see that at a high spatial and temporal resolution. But one of the challenges we've got, and put a bit of thought into this, is that the routes that we're observing may or may not be the preferred route under normal conditions. So we've been developing a method to basically classify routes on a diversion route, or what could be classed as a diversion route, according to whether it was likely that the vehicle was traveling on a rerouted trip, or whether that was a preferred route under normal, and that they would have selected in any case. And so that's sort of one of the things that's a bit complicated. The other thing to bear in mind that I haven't presented here is that we've also got before and after data. So we can look at what vehicles would normally do and learn from that, and as well as and compare that with the conditions during the event of interest. At the moment, we've not really done much on trips that don't take place at all, or are postponed due to some road closure or sort of the wider storm event. I'm not sure if that's entirely possible with compass data on its own. I think the compass data could add insight into that, but I think you need to be picking up data from traffic counts, fixed location traffic counts, and that sort of thing, in order to develop a more comprehensive picture of what's happening across the network. I think moving on to the second point, we've also got the estimation of vehicle delay in affected routes, which I've presented, and we could do the same thing if we are able to understand which vehicles are rerouting. I think we get an enhanced understanding of that, and the not just the road section by road section approach, but we can also look at origins and destinations, which is not something I think either has really mentioned it during the sort of introduction to the data, but each individual vehicle trip has an origin and a destination, as well as the route followed, and we can use that information to understand how different origins and destinations spatially across a network could be affected. The other thing is, when we're talking about rerouting, because every trip recorded has a separate origin and a destination, you need a separate process for examining the route followed. It's computationally quite challenging to look at each individual trip on its own, but that's something that we've been working on in the background. We can use vehicle behavior to identify and characterize incidents, as I've shown, but these are known incidents. These are incidents that we knew had happened. But also another thing that we're interested in trying to do is to basically train a model to identify and maybe characterize incidents that aren't recorded, or are recorded but not in an easily retrievable way, which is often the case, particularly in local roads where we've got 32 different local authorities with different systems and different levels of resource. And so we think that, in terms of identifying vulnerable locations on the non-strategic or trunk road network, there's an opportunity to do that with the Compass data. There's questions around sampling rates. Maybe these are in the chat at the moment overall, and also biases with vehicle type and age, and maybe spatially, and maybe by road type that we need to have a closer look at. And I think there is, as I've alluded to earlier, there's the opportunity to integrate with other data sets. I don't think any one data set is going to give us the full picture, but we using public sector data sets, working with others alongside Compass can give us these insights that we don't really have at the moment. And there's obviously also the opportunity to generalize using traffic models. I know David said, why model something when you can measure it, and that's true. But also, if we're looking to the future, one of the things I've been involved in a lot is climate change risk and adaptation. And okay, we can learn a lot from individual events, but then using the knowledge we gain from individual events to develop models that show us what the future may look like in 10, 20, 30 years' time, we can use the knowledge gained from the data to enhance the calibration and validation of traffic models of disrupted networks, which doesn't really exist at the moment to any great degree, certainly not at a network level. So we can, I think there's the big opportunity to enhance our understanding through maybe playing out scenarios on the network, seeing what would happen if something, and that these models would be informed by Compass data or floating car data in this sense. Okay, so I think that's me almost bang on time, Joyce. Raced through quite a lot there, but maybe there's lots of questions.
Well, yeah, I was going to say thank you so much for that, and also for David for just giving us a bit of an insight to it. For those, now there are lots of people here who know lots about geospatial data, so that they will be like, there's some of their questions in the chat here, and there's maybe some that are maybe beginners like myself to this. So I'm going to go. David has been working his way through the questions on the site as well. Thank you. He's double dipping and his attendance here. But I'm going to go through and I'll get to the questions. Okay, so these are ones that have sort of been answered, but people haven't seen in the chat or maybe on the phone and can't see them. So William Connell asked about what types of vehicles you're tracking, and also Fiona Carson asked about what proportion of vehicles travelling on the road do you typically get data from? So I don't know if you can pick up those, maybe they're quite straightforward ones, or maybe not, looking at David's answer to Fiona's question.
Yeah. Well, I mean, yeah, how long's a piece of string, I guess, is the answer. I don't know if you did any validation, Neil, in your work. Okay. Yeah, so
sorry, David, I'll come back to that in a second. I've got one or two observations. I don't think it's as statistically significant as calibration, but I'll come back to that. If you go first.
Oh, yeah. I think we don't collect or store AADT from the network, so we wouldn't know that unless we did a validation exercise. But what we generally would find on sort of, especially main arterials and freeways and things like that, you'll get quite a good representation in sometimes up to even 10% of the network. However, with adherence to the GDPR, we remove the first 5 edges of each trip, which is to say, if you're familiar with OpenStreetMaps or links, we remove the beginning and end of trips to mask, I guess, the true origin destination of each trip, right? So local roads might have a little bit of a dip in coverage because of that. And so, yeah, there's a few nuances there. Hopefully that answers the question.
And David, could I just say, for the non-experts in the room, what is AADT?
Oh, sorry. What does that stand for? The daily volume.
Annual average
Yeah.
daily traffic.
Yes, that's the one.
Okay, see, we use these
So-
things and then we're like, oh, right, what does it actually mean? Okay.
Yeah.
Now, Drew, sorry, Neil, you want to say something there?
I was just going to say that we were looking at a part of the Scottish Road network that where the data is fairly sparse. We knew that when we got the data, but actually that helps us because we can really drill into the data and see if it's doing what we expect it to do. I think, having spoken to your colleagues, David, that if you had a data set for 2025, there would be a higher sampling rate.
Yes.
But you know more about that than I do. But the sampling rate was pretty small in that part of Scotland. Therefore, correlating the observed vehicles from Compass with the annual average daily traffic or annual average is quite hard. So changes in flow, we've looked at changes in flow across that part of the network, and it's quite hard to detect with the Compass data, but that's what we expected. We didn't expect to see anything dramatic because the sampling rate's quite small at that time.
Yes. Yeah.
And I think, David, you've said in the chat there, it's about that it's these fusion data projects, isn't it, that will yield the richest information insights. And that probably covers a lot of the questions that have been asked. And speaking from a Scottish Government data division perspective, it's like that's what we are really trying to encourage is people to kind of use open data, to publish more open data, to use data standards, to increase the interoperability and reuse of data. So, this definitely all fits within, because not only does the public's, the citizens of Scotland benefit in lots of different ways from that, which could be public sector being able to do things more effectively, but also other products coming to market that will support, so that's all good. And already we've had an inquiry, just to flag that up. Scottish Roads Network, Jason has said I don't know if you've picked up on that, but we'd like to have a chat with you. So there's an email there. So that's just great.
That's fantastic.
So going and I see a colleague from Transport Scotland, who well Kent face around these parts, Drew, has asked a few questions here. Just asking, so his first one was about how well have the diversion routes been observed?
Well, okay, so we looked at two incidents where traffic flow was quite low anyway. So on the first incident, between Dingwall and Ullapool, we couldn't see any vehicles that had diverted. Partly, we assumed because the diversion was so unattractive, people probably would just decide not to bother. The other one, the official diversion route was used some of the time, and an alternative route was used on other occasions. I was playing about with Open Route Service just to see what it would tell me to do, and it told me to use the non-official diversion route even if the A9 was open. So there's actually this is one of the points about using routing services that don't have an accurate traffic speed linked or within them, because you get these over optimistic diversion routes or maybe unsuitable diversion routes. So anyway, to answer Drew's question, sometimes yes, sometimes no.
That's good. Maybe
Which is what you would expect.
And I was going to say, I picked up on, you said actually and kind of early on in the presentation was mention of climate change and environment, and I suppose, and environmental impact. And there's a question about has the environmental, this is from Drew again, and the environmental impact increased like noise and air quality? I
We
don't
haven't
have got
looked
much.
at that, but if there's a fairly standard approach between, I mean, guess you could. I mean, absolutely, because you've got vehicle speed, you've got acceleration, deceleration, you've got vehicle type. I think you can do the noise calculations around that.
Yeah,
Okay.
I think just building on Neil's comment, I think I've seen in the US some research that's sort of widely accepted around tracking trajectories and phasing. So what sort of effect does phasing have on emissions as vehicles slow down and speed up? So we can get individual traces of vehicles to get a sense of that. We also can script, because we sort of get information directly from OEMs. We can at times script for the fuel type of the vehicle, so we can understand if it's an EV or an ICE vehicle, and then fuel state or charge state, and things like that. So there are different ways where we're learning to leverage the data. I think it's like we're 2% of the way there, right? Like very tip of the iceberg in terms of what's possible. Yeah.
Well, I was going to say shout out for Wales. So Matthew's saying we have access to data back to 2020. So there you go. You know, then maybe there's some learning there for people to connect. And there's a post here from Jonathan Law saying, is there any chance this data being made available via Open Data Scott? I imagine it'd be really interesting to look at anything from Compass there. That may be a thing to look into, David.
I'll get back to you. Good question.
Yeah. That's okay. No, that's okay. Yeah, so it really feels like you know, I think all of us here, you know, just looking at the questions, how people can see, you know, very quickly how this sort of bringing all of this together, and I'm just I saw that scrolling through all the questions as they kind of come in. I wanted to pick up one. This is an interesting one because it's probably something I don't know if either of you heard of Savvy. SAVVI. Now, this is a scalable approach to vulnerabilities. Now, that is a new, well, it's a program that's been around for a while, but I think now is coming into the improvement service, which within Scotland, and a new team are being formed there. So this is looking at all kinds of vulnerabilities, so that might be a useful connection. Roger, I don't know if you're there and can post in, you know, where would be a logical place for people to reach out to, or a name would be good while this work is kind of new. No. So, and we've got more from the Scottish Works Roads Register there, so we're going to go through that and make sure that we're connected, you know, make sure that everybody's connected to everybody else that needs to be. And I think Drew's picked up on, could a wide range of data sets, including a range of connected vehicle data, be accumulated to evaluate the cost of climate change and perhaps network and identify network changes? I don't know what your reflection are. He said that AI's role in this would be interesting. Any thoughts on that? Nodding.
Yeah, Neil, you probably got lots to say, but just even one example that I've been so excited to work on, actually. So everyone knows the Sydney Harbour Bridge in Sydney, right? Like it's the big coat hanger. We have many movable lanes on that bridge that accommodate for northbound traffic in the afternoon and then southbound traffic in the morning, according to, you know, peak flows. What we found recently was that there are a few engineers that know how to operate those lanes, but only a few, and there is no way to simulate their training. So you're learning on the job and you're doing it right, or you're causing like extensive congestion or issues by not performing that task. So we were able to feed real vehicle trajectories into a digital twin model, which then leveraging AI is able to build a simulation model where people can now sort of learn and train in a simulated environment rather than on the job. So many projects like that are emerging. That's just like one of many things, but we're super excited around like what AI can sort of do on top of this, I guess, a whole bunch of field studies, which are now much more available. Yeah.
Great. Neil, do you want anything to add to that?
The question was about adaptation. Is that correct?
No, I've lost.
Leveraging AI.
Leveraging AI.
Yeah. Leveraging, yeah. Well, absolutely. I think one of the things that inevitably doesn't happen, as well as somebody sitting in an office like me might expect it to happen, is when you have disruption across the network, you get people out there in all weather, all times of day, keeping people safe, making sure, trying their best to sort of keep roads open or closing them down if necessary and opening them up, and all the rest of it. So what happens is that the data side tends to be somewhat neglected, particularly when people are really busy. And so incident records, if you're looking at a historical analysis of what's happened, it often gives you an incomplete picture in many ways. And I think there is plenty of scope for data of this kind to fill in some of the blanks. And therefore, you begin to learn about how the network performs. And once you get to that point, you can start projecting or thinking about the future. Or different scenarios. Maybe it doesn't need to be the future, but different scenarios. What would happen if this event occurred? And I think that could be used for planning and management purposes, but also for training, as David mentioned. Absolutely.
Yeah, because actually the question that was the finale was about AI. The question was the core of the question was really about that ability to better evaluate cost of climate change events.
Okay, I can keep going because just briefly, just conscious of time, but I mean, in a nutshell, everything that we look at requires us to write a query of some sort of the data, and we need to know what we're looking for, or it's a fishing expedition, and we need to sort of somehow surface what's happening in the network, given the sheer volume of data that we've got. Something that can do that in a more intelligent way than a human being looking at a computer screen could be pretty helpful. And so it's not something we've done anything on, but it's in the back of my mind that would be really helpful to have assistance of that kind. Might be able to sort things in a particular way that you can zoom in on what's important.
Right, that's really good. And I was just to say, there's a Wibber question, which I think is following on from David's discussion of which I didn't know it was called the coat hanger locally. Sydney Harbour, such news every day's a school day, right? How far back does the process need to begin in order for lane changes to be effective? Hopefully that's a very specific, short question. That's the very last question in the.
Terence. I mean, okay, that's a big question. So I mentioned before in the chat that we can get very, very specific GPS locations and trajectories so that we know where vehicles are changing lanes, merging, all of that kind of thing. It does require, because OpenStreetMaps doesn't give us lane information, we need to go and look at the road in terms of with photography or aerial imagery and actually plot those lanes. Thanks for whoever's Drew for putting that photo in. It does look like a coat hanger to me. It does. We all call it the coat hanger in Australia. But anyway.
There you go. Wow.
Yeah. So it's a process that we are working on automating. It's a little bit more difficult than your average, but it's certainly something we're looking at. For example, in the USA, a lot of high vehicle occupancy lanes, so buses sort of can use these lanes. Normal vehicles are not supposed to. So we're sort of looking at how vehicles do or don't use or comply with those rules. Yeah, those are some of the use cases.
Isn't it typical? I pick the last question out and said it's a very complicated one. I didn't intend for that to be the case. Sorry. Okay, listen, we're coming towards our closing time. Is there any? Neil, is there any sort of call to action here that you would like? Is there anything that anybody here listening? Some people have already put kind of emails in and wanting to connect with folks. Is there anything that would be helpful for people that you're looking for? You said that. There was, with other data sets that you'd be interested in, like this is your chance.
Yeah, I think some of these data sets actually lie within the public sector, and some of these are not nicely cleaned data sets. They might even just be paper data sets.
Yeah. Okay.
And these sorts of things are unretrievable or costly to retrieve, and therefore are not given very high priority. In order to do our kind of work, working out how to access that and make sense of it, and resource that side of things is part of the process. Yeah. And then there's the sort of fusion of data, the interoperability that was mentioned earlier. Yeah.
Okay. So what I'm going to say is, obviously, what I want to say is that thank you to everybody who has put questions in, put comments, put emails in. It's always these sessions you think, as people are listening in, that's quiet and think, oh, like nobody's going to ask anything, and then suddenly there's pun totally intended, but floodgates open and lots of questions come out, and then we don't necessarily get to all of them and everybody's point. So what I would say is to people, we will what we'll ensure is that we'll get some material up onto the Data Lab community. So there's the Data Lab community has many, over 6,000 members there, and our little niche of it is the public sector community. So if you're not a member there, please do join. We will post material there. Neil, would you be okay to share these slides that you've
Yes.
presented today? And David, is there anything you would like to share? Because we could publish that too if there's something relevant.
Certainly, I can share sort of a slide version of what I showed you today, and very happy to chat more with people. Thank you.
Brilliant. And also for the people that couldn't see what, I think either the diagram, the picture you did earlier on, then hopefully you'll be able to go on and see that. We will be, this is a place where, we post lots of material there. Paul, who's here from the Data Lab, and myself and some of my colleagues post here regularly, but it's also a place where you can post. There's also lots of other communities. So there's a whole massive geospatial community, so well worth looking into that, and lots of other ones. So there might be something that speaks to you. And there's also lots of the Data Lab put on lots of brilliant events that you can summon, some even in person with if you're local, and so you can come in person. And we've got these ones here, which is kind of these are all sort of online, but who knows, maybe some point in the future we will go on the road, pun intended. We will so we'll wrap up. We'll kind of wrap up there. I don't have a date for our next event, but what I can say is we won't be having one in July because that is obviously traditional holiday season. So I think we'll be looking towards something towards the end of August. So keep an eye on the emails that you get from the Data Lab team. So we're 12:50. It's time to get ready for your next meeting or go and get your lunch, whatever you want to do. But thank you so much for your time and joining us here. And thank you to our speakers for such an interesting way to spend a lunchtime session. Thank you so much to you both. Thank you. And thank you to Paul for helping us host it. Have a good day, everybody.
Team.
Bye.
Bye.